What is up, guys? It's TimeForDillon back at it again with another crypto video. What is up, guys? It's TimeForDillon back at it again with another electronics tutorial. Once again, we are diving into our Elegoo Uno R3 most complete starter kit in the known observable universe. No, I'm just kidding. But in today's lesson, we're doing lesson number 11, where we're talking about the membrane switch module. So this thing's pretty cool because, as you guys can see, we're going to talk about how to integrate a keyboard with the Uno R3. That's basically what this thing is. It's basically a little keyboard. We're going to make it so that this Uno R3 can read the keys being pressed by you, the user. So, without further ado, let's jump into today's lesson. Make sure you guys stay tuned until the end so you don't miss out on any of this important information. If you guys saw my last video, I showed you guys exactly how to implement our SODAR example. Not only with our Arduino IDE, but in the last video, which was an hour long. I know, the longest video I've ever made on this channel. If you guys want to check that video out, link will be down below in the description. But without further ado, let's jump into today's lesson. What we have to do, of course, is pull out our components. It looks like all we need is our membrane, our Uno, and 8 male-to-male jumper wires. So let's jump into our box and get our components out. So, of course, bingo bango, we got to pull our things out. I took my cable off last time we did our video, but we need our cable. We need our Elegoo Uno R3, of course, everyone's favorite. Then we need our membrane switch, which, let's see where that thing is. I actually don't know where it's located. Oh, it looks like it's right over here. Bingo bango, whatever that means. Here it is, our little membrane switch with the connector. And then, of course, like we said, 8 male-to-male jumper wires. And then, of course, put this to the side because we no longer need anything out of this box. Bingo bango. Alright, so let's read into today's lesson. So like we talked about, in this project, we're basically going to learn how to integrate the keyboard with the Uno R3 so that when you press the buttons, the R3 will pick up what the user is pressing. So keypads are used in all types of devices: cell phones, vacuum machines, microwave ovens, door locks, everything. Think about where you've used keypads. I can think of one example right here. My Baofeng UV5R radio. Boom, that's a keypad, isn't it? Yes, it is. Everything has keypads. Everything has buttons that are pressed that are picked up in a digital or analog signal and are switched into some form of code which processes something. So this is a pretty valuable lesson. So knowing how to connect a keypad to a microcontroller such as an Uno R3 board is very valuable for building many types of commercial products. So at the end, when all is connected properly and programmed, when a key is pressed, it shows up in a serial monitor on your computer. Whenever you press a key, it shows up on the serial monitor. For simplicity purposes, we start at simply showing the key pressed on the computer. But think about how we can implement it into the last project that we just did, which was building that radar system. Think about maybe if you put in a certain number, it will turn the servo, boom, to that degree. I don't know, something like that. Or maybe you press A, and it'll make it spin at a certain rate. You press B, it'll spin at a different rate. You press D, maybe it will stop spinning. I don't know. Just think how you can implement these certain key presses into code that does something. So for this project, the type of keypad that we will use is a matrix keypad. This is a keypad that follows an encoding scheme that allows it to have much less output pins than there are keys. It has 16 keys, see, 4x4, 16, 0 through 9, A through D, star, and pound, yet only 8 output pins. With a linear keypad, there would be 17 output pins, 1 for each key and a ground pin, in order to work. The matrix encoding scheme allows for less output pins and thus much less connections that have blah, 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 blah. Cool. So my guess is the way that this works, looking at the schematic, as you can see, there's 2 numbers that are tied together. Or maybe star and 7, 4 and 8, 1 and 5, 2 and 6, 3 and B. I don't know how they connect, but clearly there are 2 connections. They're probably like if blocks. If you press it once, it does this. If you press it again, it goes to the other one. That would be my guess. I really don't know. I guess we will figure it out once we look into the code. But this is how we're going to be wiring this thing up, looking at the schematic, looking at the wiring diagram, which makes it a lot easier. It looks like we're just going in from one side, so it looks like the D side, we're going to start with this pin, and we're going to connect this one to 2, and then moving this way, 3, 4, 5, 6, 7, 8, 9. Cool, looks pretty simple. So let's go ahead and start wiring this sucker up. So let's switch our view. All I'm going to do, of course, is just connect some wires to this sucker. I don't really think the orientation matters too much. Clearly, they're all male-to-male wires, so it really doesn't matter. I'm just going to alternate colors. So we'll start with black, and we'll work our way down. All right, so after putting all of your male-to-male connectors on this sucker, basically the way that we're going to wire this is starting with this D side and moving that way. If you look at our schematic, boom, we're going to go 2, 3, 4, 5, 6, 7, 8, 9. Starting with the D side, moving towards the star side. So I already have this sucker wired up. Now we just need to connect it to our Uno R3. Like I said, starting with the D side, just go into 2, 3, 4, 5, 6, 7, 8, 9, all the way up. Pretty simple. Bingo, bango. So when you're done, it should look like this. See, we have it wired in from the D side, starting at the 2 pin and working our way that way up to the 9 pin. So you guys could see. Boom, that's how we wired it up. Just follow the schematic. This one's pretty simple. You really can't mess it up. All right, so going back to our lesson, let's go ahead and plug this sucker in. We are now plugged in. And let's read. When connecting the pins to the Uno R3 board, we connect them to the digital output pins, D9 through D2. We connect the first pin on the keyboard to D9, the second pin to D8, blah, 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 up to D2. These are the connection tables. Cool. After wiring, please open the code in folder 11. So what we'll do now is go ahead and open. Go to our code, which is on our desktop. Elegoo, boom. English code 11, and we will open up this INO sketch file. We can close this other one, make this big, and then of course make sure that we have our correct things selected, a port and our device. Let's see what else it says. See lesson 2 for uploading blah blah blah. Before you run this, make sure that you've installed the keypad library. So let's go ahead and look to see if we have our keypad library. KEY PAD. We'll go ahead and install the keypad library, which is now installed. And to do that, you just go up to Tools, Manage Libraries, which I already have open, so I'll close it now. Let's go ahead and run it, and then we will see what's going on. So I just deployed the code. We'll open up the serial monitor, and when I start pressing buttons, let's see if you guys can see. I'm going to start pressing buttons. So here's 1, 2, 3, all right, 4, 5, 6, 7, 8, 9, star, 0, pound, A, B, C, D. Very cool. So this thing definitely works. Very cool to see. So let's look at the code and see how it exactly works. So this is just some information about the person that created this library. Pretty cool. Shout out to this guy. We're including keypad.h, which is what's created by this homeboy right here. And it looks like the way we're doing this is const byte rows equals 4. So what does byte mean? So I looked it up. Why use const byte instead of const int? And it seems that the reason why is just to save a little bit of memory, but I don't think it really matters. I guess, you know, if you're developing a project, you're developing some sort of product that you want to sell to people, you want to optimize the amount of memory that you're using, use const byte for your dimensions of an array, right? This is a 2-dimensional array of characters. Optimize the memory just a little bit. It looks like byte is only 8 bits. Int is 16 bits, twice as much memory. Although I don't think it really matters between you and me. But that's why they used byte. I was curious, so I had to look it up. So it looks like, boom, we're defining the dimensions of this 2-dimensional array. So two-dimensional array, it's just like what we've been doing. We've been doing one-dimensional arrays. Now just imagine that each element of the array is another array, right? And in this case, we have an array that holds 4 characters, except each spot of the array holds another array that holds 4 characters. So we have a 4x4 matrix, which is just a two-dimensional array. So for the row pins and the column pins, these are the pins that we talked about in this situation, right? So for our pins, like we said, we're going from pin 9, D9 to pin D2. So this is how you would set up the pins in this case. We have 9, 8, 7, 6, 5, 4, 3, 2. These are the pins that we're using in this case. So we're going to initialize an instance of class new keypad, which this is not correct. The class name is not new keypad. The class name is keypad. Why did he put new keypad? So we're calling on the class name keypad. We're naming our instance of that class custom keypad. So this is going to be the name or name of the object or the name of the instance of the class that we're using. And then when we create it, we're calling on the constructor to create that pin. And we can go ahead and look at this code if we go into our documents folder, boom, Arduino, libraries, where's the keypad? And we can go ahead and look at the source code for the keypad, boom, open with Notepad. This is our keypad class. So if you want to create an instance of this class, right, an object, we name it custom keypad, you need to call the constructor. And it looks like in this case, there's only one constructor. And to do that, we need to send in 1, 2, 3, 4, 5 different parameters. So the first parameter is use keymap. And it looks like for this keymap function, or this keymap variable, we're sending in our two-dimensional array. So this is the map of the keys. Cool. So then we need to send in the row, the column, which we do, row pins, which is right here, column pins, which is right there, num row and num column, basically how many columns, rows, which is the number of rows, and calls, which is the number of columns. So that's how we create this instance of the class. So just like in every single Arduino sketch we do, we have a setup and we have a loop. So in the setup, all we're doing is we're setting up the serial monitor to begin reading data at this baud rate, 9600. And then in our loop, what we're doing is char custom key equals custom keypad, which is our instance of the class, our object that we created, dot get key. So what does dot get key do? Char keypad. So char means it returns a character, which we call a char. And the way that we return that is by calling this method of the class, right? A method is just a function that is that's tied to a class. So the only way you can call get key is if you have an instance of this class, right? This class, we have an instance right here. And you do so by naming our instance of the class, putting a dot, and then calling the method. So in this case, it doesn't need to take in any form of parameter. See, all you do is you just call it, and what it does is it returns what it is. So in this case, we're setting it equal to custom key. So we're creating a variable, and we're going to store whatever it is that we're calling from this method. And see, since we're looping, it's constantly looping. Bump, 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 bump. Whenever we happen to press a key, like I'm going to press one right now, boop, it runs this function, boom, or it runs this method. It gets this key, it stores it in this variable, and then we run an if custom key, which basically if you just put if custom key, it means if there's something in custom key. If there's something in the character, if it's not empty, basically. And if it's not empty, what are you going to do? You're going to print it out to the serial monitor. Serial.println custom key. And remember, the difference between print and print line is that print, and if we just change this really quick and deploy the code, print will just print it, print line prints, and then it gives you a new line. Okay, so it's done uploading. I took off the ln so you can see it's going to put everything on a new line when I press all these buttons. Or it's not going to put everything on a new line. Sorry, it puts everything on the same line. So that's pretty cool, right? That's pretty much how this code works. Pretty simple. I guess the hardest part would be creating the map and then figuring out which pins to connect it to, because you could technically, theoretically, if you were setting this up on your own, you could run into some problems if you mapped the wrong numbers to the wrong pins. Then if you press, 1, 6 might come up, etc. You get the point. But as long as you use this code here, now we understand how it works. You can definitely implement this into a program. But that's pretty much it for today's video. I might be making another video showing you guys how to set up like a very simple calculator, just so you guys can see how to do it. All it would really involve is just setting up maybe a couple different character variables and then a couple if statements. So, you could set up maybe like A for add, right? A for add, B for subtract, C for divide, or maybe D for divide, C for multiplication. And then, when you press multiple numbers, boom, you can press V, and then it will press the pound number, and it will spit out whatever it's equal to. Stay tuned for that lesson, because that's coming soon. That's all I have for you guys today. If you guys made it this far, you guys are awesome. Make sure you smash that like button, drop a comment down below, and of course, subscribe to the channel if you haven't already. Thank you guys. Have a beautiful day, beautiful night, wherever you guys are. Dylan is out.